This is the first part of chapter 14 talking about compounds who have oxygen, sulfur, or a halogen. Now we start with alcohol, where the functional group is OH. It's going to be bonded to a saturated and alkane-like carbon atom. Review the learning objective, be able to describe the structural differences between alcohol, phenol, and ethers. And I'm not going to go over the learning objective later. Now just giving you some examples here, phenol is the one that has an OH group that is bonded directly to an aromatic compound, the benzene-like ring we went just earlier. So right here in the middle is the phenol. You have the benzene-like 6 carbon atom, double bonds, and OH attached to it. On the far left is the ethyl alcohol. We're going to learn how to name those. And on the far right is called ether. This is where you have an oxygen atom bonded to two organic groups. We refer those as R and R prime. In that example, diethyl, because I have an ethyl on the left side, oxygen in between, an ethyl on the right side, so it's a diethyl ether. Many times, and please read this, there's common name for the alcohols, and those are the ones are going to have different name than the IUPAC definition we went over earlier. Now, how do you do this? Well, you identify the alkyl group, and then you just add the word alcohol. So far left, I see 1, 2 carbon atom attached to the OH is the ethyl alcohol. 1, 2, 3 propyl alcohol, 1, 2, 3, 4 butyl alcohol. How to name those? Still the same thing. First, name the parent compound. Find the longest chain that contains that OH, the hydroxyl substituent. That OH is the one that gives you the parent name, like your first name. Now here, if you look at this, I have 1, 2, 3, 4, 5, 6 carbon atoms, so I know it's going to be a X something. Symbol bond, so it will be a hexane, but I see a OH, so it will be a hexanol. Now here, I'm going to have to just name it as a hexanol and say where that OH is located, which carbon atom is going to be. We'll see more about this, it's not a complete name. If it's a cyclic alcohol, just add OL at the end, and that's something that will help you recognize right away those are alcohol. This is called cyclopentanol. Cyclo because you make a cycle, pent, I count 1, 2, 3, 4, 5 carbon atom on my cycle, attached to OH is a cyclopentanol. Then second step, number the carbon atom in the main chain, and you have to start with the end that is nearer to the OH hydroxyl group. Don't need to look at the location of the other substituent. So here I have to start on the right side because 1, 2, 3 is where I have the hydroxyl OH group. If I were going from left to right, there would be 1, 2, 3, 4. So I go with the lowest number. When you have a cyclic alcohol, you need to start numbering the carbon atom with the carbon that bears that hydroxyl OH group. Then you go into a direction, clockwise or counterclockwise, so you can give the other substituent the lowest possible numbers, always the same rule. So here I will go from number 1 OH, go down to my methyl, CH3. I won't go left 1, 2, 3, 4, 5 and get CH3 at the end. And then you just write the name, like we said before. Write down the number that locate the hydroxyl group immediately before the compound name. Number all the substituents, list them by alphabetical order. Again, in a cyclic alcohol, you don't use the number 1 to say it's the OH group because we know by definition that's the one carbon that holds that hydroxyl group. Now, other example, simpler here. First step, count the longest continuous chain of carbon atom. 1, 2, 3, 4, 5, 6. It's a X something. I notice a OH on a carbon, so it'd be an hexanol. I'm going to not start from left to right, but from right to left, because then 1, 2, 3 is what holds my hydroxyl. If I were to start on the left side, that would be 1, 2, 3, carbon number 4. No, I want the lowest number, so it's a 3 hexanol. Look at the substituent, I see a methyl. Where is it? Well, OH has the priority, so from right to left, my methyl is on carbon number 5. That becomes a 5-methyl-3-hexanol. Next example on the right, count the number of carbon atoms, 1, 2, 3, 4. It's a but something. OH is at the end. Well, the end on the right is actually the first carbon atom because it's the lowest number, so it's a butanol 1. Bottom example on the left, little bit more complex. How many carbon atoms? 1, 2, 3, 4, 5, 6, 7. Hept. OH would be a heptanol. Need to put that OH on the lowest number of the carbon, so I go from left to right. Then carbon number 2 holds the OH, so it's a 2-heptanol. Substituent, I have a methyl and I have a chloro, Cl. You need to know Cl is chloro. C, chloro, alphabetical order is before M, methyl. So it's a 4 chloro 6-methyl 2-heptanol. And finally on the right side, this is a cyclo, 1, 2, 3, 4, 5, 6 carbon cyclohexane, OH hexanol. I have a methyl on number 2. Remember, OH has to be number 1, so it's a 2-methyl cyclohexanol. Then things get a little bit more complicated when you get more than one OH. That's what we call dialcohols. We actually name them as diols. They have 2 hydroxy groups on the same molecule. How are we going to name them? Well, it's pretty simple. You're going to have 2 numbers that tell you where the carbon bonded to the 2 OH group are placed. And you're going to use the numbering number starting at the end closest to the one of the OH group. So here on that example, 1, 2, 3, 4, butane, OH, butanol, 2OH, butane diol. Now, if I start on the left side, it's going to be here 1, 2 OH, 3, 4, 5 OH. If I start from the right side, OH on carbon number 1, the second one is on carbon number 3, lowest sum. So it's a 1, 3-butane diol. Right side, 2-methyl-1,2-propane-diol. Another name is isobutylene glycol. I won't ask you to know this. So how do I do this? Well, again, 1, 2, 3 carbon atom, longest carbon chain, it's a propane, single bond, OH, 1, twice, propane diol. Start numbering where I start with the lowest number on the carbon for the first OH I encounter, so it's number 1, then second carbon number 2, 1, 2 propane diol. I do see a substituent which is a methyl, which is placed on carbon number 2, so it's a 2-methyl-1,2 propane diol. I don't go through the other example, I think it's pretty straightforward. Sometimes we refer those diols with 2H group on adjacent, meaning right next to each other carbon atom. We call those glycols. I won't ask you so many questions about this.